Okay, so we are going to start talking about synthetic substitution. Do you guys remember synthetic division? Yeah? Fun, right? So today we're going to do synthetic substitution. What that means is this. All right. All right. So take a look. You have this function here, f of x, right? You want to find f of 3, all right? There are 3 different ways we can do this. The first, you've known how to do this ever since you were like so little, right? It's called direct substitution. This is basically when you just take 3 and you plug it into the function, right? So f of 3 is 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11. So this is 3 times 27 minus 6 times 9 minus 8. And that will be 81 minus 54 minus 8. So f of 3 is 19. Okay? I mean, easy enough, straightforward, kind of annoying if you don't have a calculator, right? But it is what it is. Okay? Another way you can do this is by long division. So you want f of 3, right? So you imagine that came from a divisor, x minus 3, that when you set it equal to 0, you get x equals 3, right? Yeah? So x equals 3 comes from the divisor x minus 3. So what we're going to do now is we're going to do long division with this. So here we have x minus 3 on the outside. And then here we have 3x cubed minus 6x squared plus x minus 11. No exponents missing, so we can just go ahead and do that. 3x cubed over x, we get 3x squared, right? So we're kind of reviewing at the same time. You multiply the whole divisor, 3x cubed minus how much? 9x squared. What do we do now? Change the sign. So this goes away. We have 3x squared. Bring down the plus x. Divide this by this now. So we're going to get plus 3x. Multiply it out. 3x squared minus 9x. Minus plus. I get 10x minus 11. Divide 10x by x. I get 10. 10x minus 30. Change the signs. What do I get? 19. So now, what happened? What was f of 3 supposed to be? 19. Where does 19 show up? Right here, the remainder. So another way to do that, right, if this is like a little too boring and mundane for you, you can do this, and the remainder will be your y value, okay? Will be your f of x. Now, there is a third way to do it by synthetic substitution. So here we put the 3 because we are finding f of 3. And then the coefficients go in here. 3, negative 6, 1, negative 11. 3 comes down. Multiply by the outside 3. Add, multiply, add, multiply, and I get 19. Again, this is f of 3. Okay? So here too, this, the remainder, is f of 3. Okay? Questions? Okay, so this is fine. The direct substitution, this is fine when you're, like if I have, for example, f of x is x squared plus 2, and I want to plug in a 1. Okay, I'm not going to do this, right? But imagine instead of plugging in 3, we were plugging in 17. You don't want to do that, by hand if you don't have a calculator. So this is the synthetic substitution is a much better way to do it. So when I ask you to find the value by synthetic substitution, that's what I'm talking about. Okay? All right. So we don't know what the graph of this looks like, but we know when x equals 3, f of x is going to equal 19. Okay? So I don't know what the graph looks like, but at x equals 3, y is 19. That's what I know. Okay? All right. So let's talk about the factor theorem. When polynomial division produces a remainder of 0, right? When we do polynomial division, whether it's long division or synthetic division, when the remainder comes out to be 0, we say the divisor is a factor of the polynomial. Okay? And the quotient is called a depressed polynomial. All right? So take a look at this one. Determine if x minus 3 is a factor of this. So what do I mean by factor? All right. If I ask you, is 4 a factor of 24? Is 4 a factor of 24? Why?
It goes into an even amount of times.
Right, because when you divide, what's the remainder?
There's no remainder.
There is no remainder. The remainder is 0, right? When you divide 24 by 4, the remainder is 0. That's how it's a factor, right? So if we want to find out, is x minus 3 a factor? We divide, and if the remainder is 0, then yes, it's a factor. Okay? So let's do this. From x minus 3, we get 3 out here. So here we get 1, 4, negative 15, negative 18. 1 comes down, multiply, we get 3, 7, 21. 21 minus 15 is 6 these days, 18, 0. I get a remainder of 0, so yes, it's a factor. Okay, so let's go back to our example of the 24 and the 4. So 4 is a factor, right? It means I can write 24 as 24 equals 4 times some other number. Is that right? How do I find that other number? It's 24 divided by 4. Whatever I get is 6. Yes? So now, if this is a factor of that polynomial, that means I can say f of x is equal to x minus 3 times something else, right? If x minus 3 is a factor, that means x minus 3 times something else equals that f of x from before. Well, what is that something else? I get that from this. It's the depressed polynomial, right? So remember how we do this? If this was x cubed, when we divide, the exponent goes down by 1, so it becomes x squared. So it'll be 1x squared plus 7x plus 6. So it'll be x squared plus 7x plus 6. Okay? And guess what? I can factor that even further. X minus 3 times, how do I factor this? Correct. Okay, so have we done everything the question was asking of us? Okay, so yes, good. So what have we done so far? We determined if it was a factor. We found the other factors of the polynomial. Now I just need to graph it. Okay, so what are the zeros here? X equals what? Negative 1, 3, and negative 6. So negative 6, negative 1, and 3. Okay, now we have to decide, do we have a calculator or do we not have a calculator? If I don't have a calculator, I actually can still graph this. Do you know how I can graph this? Do we know the end behavior of this? Yeah? The end behavior, remember? So this is a whole lot of review, right, that we're doing. This is why I was okay with doing the quiz so soon, because in this lesson, we also review so many things. So look at the leading term of this, x cubed. Remember, this is an odd degree, So one end is going to be up, one end is going to be down, correct? If it's positive 1x cubed, is the right side going to be up or down? Up. Good. And the left side is going to be down. Okay? So now, based on this, we can graph this polynomial and we can say it's going to look like this. The only thing we do not know if we don't have a calculator is the location of the minimum and the maximum. So we can kind of eyeball it. We know it'll be somewhere in between these two, that there is a maximum, somewhere in between these two, that there is a minimum, and we don't know how high or how low it is. With a calculator, though, we can like pinpoint exactly. All right? So look at that. In your wildest dreams, did you ever think you could be given an equation like this and you could graph it without a calculator? Look at how amazing this is. I mean, listen, if there was ever a way to kick off 2024, this is it. I mean, seriously, what better way, right? I mean, honestly, look at this. You grabbed this. This is the first thing you did in math. I mean, dude, this is exciting times. I don't know. Okay? Come on. All right. So, now let's do it again, right? All right, let's do it again. Okay. So, now look at this one. It says, given a polynomial function and one of its factors. Okay? That already tells you when I divide these two, I'm going to get a remainder of 0. Okay? One thing here, this typo, I guess I didn't catch it. These should all have f of x equal. Okay. So, let's first graph. Let's first divide. Positive 1. Thank you. I just got so excited about the graphing. Okay, so 1 minus 6, 11 minus 6. 3, 2, 1, 0. Okay, so 1 comes down. 1 minus 5, minus 5. 6, 6, 0. Okay, that satisfaction when you get a 0 is unparalleled, right? Unparalleled. Okay, so f of x is equal to what? Help me out here. X minus 1 times what? Correct. Now, I can factor this even more. Yes, I can. X minus 1, x minus 3, x minus 2. So the zeros are x equals 1, 3, and 2. Oh, isn't that cute? All lined up. 1, 2, and 3. Now, there are more things we can do here. So the leading coefficient is how much? X cubed. So again, it's going to be, going up to the right and negative infinity to the left. We can find one other thing. Can we find the y-intercept of this? What's the y-intercept of this function? You guys know. Yes, 0, negative 6, right? So, that narrows it down a little bit more. So it zeroes it down, get it? Haha, okay? All right, so look. Up, we're going to go back down, and we're going to go back up. Okay? Isn't that cool? Say yes. Yeah, it's amazing. Okay. All right, so a little bit. So now we know if x minus 1 is a factor, the remainder here is 0, right? We just learned, though, here that the remainder is the y value at that point, correct? So let's take a look at this for a minute. At x equals 3, the remainder is 0, which makes sense, right? Because it's one of the zeros of the function. So of course the y value is 0. And then, so if I were to take, let's say, x equals 4, whatever other number remains is the difference of that from the 0 to that point. Do you see what I mean? Isn't that cool? That's why it's the y value, right? Math is so cool. Like, you guys have no idea. Math is so cool. All right. Okay, so let's do this. Oh, we're almost done. Okay, so given a polynomial and one of its factors, find the remaining factors of the polynomial. Easy. Let's do this. What goes out outside? 3. And here I have 1, -1, -5, -3. Let's check the exponents. 3, 2, 1, 0. We're good to go. 1, 3, 2, 6, 1, 3, 0. Yes. So now, look at the instructions. We are told, given a polynomial and one of its factors, we are told x minus 3 is a factor. So when you do this synthetic division, and you don't get a remainder of 0, the math wasn't wrong. We just made a human error. Okay? Because the math can never be wrong. If the math says the remainder is going to be 0, then we did something wrong. All right? So that's when I go back and I check what I did wrong. All right? So here, f of x is equal to x minus 3. And then what? X squared plus 2x plus 1. This is x minus 3. And when I factor that, I get x plus 1 squared. And I am going to require that you write x plus 1 squared versus x plus 1, x plus 1, because this exponent here, the square after the x plus 1, it has other implications that, we learn about later. Okay, so there is a difference in how you write it. Okay, so take a look at this one. So we have -2 out here. 1, 2, -1, -2. Okay, so 1 comes down, -2. Ooh, 0, plot twist. 0, -1, 2, I get 0 remainder. So what's f of x? It's x plus 2 times what? X squared minus 1. Okay? And if I factor that further, x plus 2, x plus 1, x minus 1, yes. Okay? All right. So, and of course, life would be nothing if we don't put a few decimals into the problem, right? Yes. Okay, so the approximate number of bald eagle nesting pairs in the US, you always wanted to know about that, didn't you? Right? Yeah. So here it is. All your dreams are coming true in 2024, right? Okay, can be modeled by this function p of x, where here is important information now. X is the number of years since 1970, and p, obviously, is the number of bald eagle nesting pairs. Using synthetic substitution, estimate how many nesting pairs of bald eagles can be expected in 2018. So first of all, in 2018, how much is x? Correct. So what I really want is p of 48. Okay? P of 48. So one way, until now, the way we would do this is we would take 48 and plug it into each of these x values. But it says here to use synthetic substitution to do this. So here I put the 48. No, because if you want p of 48, it'll be 48. The factor would have been x minus 48. Okay? Yeah. So the coefficients here are -0.16, 15.83, -154.15, 1147.97. Okay, so go ahead and take out your calculators. -0.16 out here. So when I multiply, what do I get for that other number? Anybody? Correct. And here I get 8.15. So what do I get up top? Correct, 391.2. So that gives me 237.05. When I multiply, is that right? Yes. So when I add, I get 12,526.4. And my fourth grader would tell me that I need a comma here. So let's do that. He's my little, comma police. Okay. So that tells me this is the remainder. P of 48 is equal to 12,526.4. That means there are about 12,526 bald eagle nesting pairs. Okay? Now, a little bit about rounding. Don't automatically round up. Just round mathematically to the correct number. Okay? Right? Because it's an estimate. Okay? Either way. All right. How do we feel about this? Pretty good, right? We just need a little bit of practice. So the quiz on Friday is going to include this lesson that we did, which, there was really nothing new. There were no new skills. It's just rewording of like a rebranding. And then 5.7 is super, super easy. So really the quiz is not even on 2 lessons. It's like on 1.5 lessons. And you guys can do this. All right, so we can stop here for today. You do have homework from the book, yes? Yes.